As an introduction to this theory section, I want to start with a very cool and very high-level overview about the JavaScript language, just so you get a first overview of most of the things that we need to learn in order to eventually master JavaScript. And this is going to be a long lecture, so get ready for a crazy ride. And I want to start by coming back to that first definition that I gave you on JavaScript, where I told you that JavaScript is a high-level, object-oriented, multi-paradigm programming language. Now, this is of course 100% correct, but it's also really just the surface, the tip of the iceberg. So what about this definition? JavaScript is a high-level, prototype-based, object-oriented, multi-paradigm, interpreted, or just-in-time compiled, dynamic, single-threaded, garbage-collected programming language with first-class functions and a non-blocking event loop concurrency model. Wait, what? Is this some kind of joke? Well, yeah, it kind of is, actually. I just packed as much information as possible about JavaScript into one unreadable sentence just for fun. But besides fun, this also gives us a great opportunity to unpack all of this in order to get a first peek into all the stuff that we're going to learn about JavaScript throughout the course. And this is not to intimidate you. It's really not. I just want you to get the big picture before really getting started, and also introduce some topics that are just good to know. Because getting the big picture before diving deep is, in my opinion, an amazing learning technique. So with that being said, let's unpack this now a little bit. So these are the 9 JavaScript topics that we're briefly going to talk about in this lecture, slightly reordered. And starting with the high-level part, as you might already know, every program that runs on your computer needs some hardware resources, such as memory and a CPU, to do its work. Now, there are low-level languages, such as C, where you have to manually manage these resources. For example, asking the computer for memory to create a new variable. On the other side, you have high-level languages, such as JavaScript and Python, where we do not have to manage resources at all, because these languages have so-called abstractions that take all of that work away from us. This makes the language easier to learn and to use, but the downside is that programs will never be as fast or as optimized as, for example, C programs. Now, one of the powerful tools that takes memory management away from us developers is garbage collection, which is basically an algorithm inside the JavaScript engine which automatically removes old unused objects from the computer memory in order not to clog it up with unnecessary stuff. So it's a little bit like JavaScript has a cleaning guy who cleans our memory from time to time so that we don't have to do it manually in our code. Next up, JavaScript is an interpreted or just-in-time compiled language. And again, we will learn more about this in this section, but what you need to know for now is that the computer's processor only understands zeros and ones. That's right. Ultimately, every single program needs to be written in zeros and ones, which is also called machine code. And since that's not really practical to write, is it? We simply write human-readable JavaScript code, which is an abstraction over machine code. But this code eventually needs to be translated to machine code, and that step can be either compiling or interpreting. This step is necessary in every single programming language because no one writes machine code manually. In the case of JavaScript, this happens inside the JavaScript engine. Now, one of the things that makes JavaScript so popular is the fact that it's a multi-paradigm language. In programming, a paradigm is an approach and an overall mindset of structuring our code, which will ultimately direct the coding style and technique in a project that uses a certain paradigm. And this definition still sounds kind of abstract, but don't worry, it will become more clear as we move on. Now, three popular paradigms are procedural, object-oriented, and functional programming. So procedural programming is what we've been doing so far, which is basically just organizing the code in a very linear way, and then with some functions in between. Now about object-oriented programming and functional programming, I will talk about them in a second. Also, we can classify paradigms as imperative or as declarative. But again, more on that later. Now, many languages are only procedural or only object-oriented or only functional. But JavaScript does all of it. So it's really flexible and versatile, and so we can do really whatever we want with it. It's our choice. We can use whatever paradigm we want. And in this course, I will show you how to use all of them. So, about the object-oriented nature of JavaScript, it is a prototype-based, object-oriented approach. Now, what does that mean? Well, first, almost everything in JavaScript is an object, except for primitive values such as numbers, strings, etc. But arrays, for example, are just object. And we already saw that in practice, right? Now, have you ever wondered why we can create an array and then use the push method on it, for example? Well, it's because of prototypal inheritance. Basically, we create arrays from an array blueprint, which is like a template, and this is called the prototype. This prototype contains all the array methods, and the arrays that we create in our code then inherit the methods from the blueprint, so that we can use them on the arrays. And this, what I just explained to you, is actually a huge oversimplification, which might still sound confusing, and that's the reason why there is a whole section on object-oriented programming with JavaScript later in the course. But since this is a big overview lecture, I wanted to first introduce this topic right here. Next up, JavaScript is a language with first-class functions, which simply means that functions are treated just as regular variables. So we can pass functions into other functions, and we can even return functions from functions. And this is extremely powerful because it allows us to use a lot of powerful techniques and also allows for functional programming, which is one of the paradigms that we just talked about before. And in fact, we have already used the power of first-class functions without knowing that they are called first-class functions. So remember this piece of code that we wrote for closing the modal window that we built before. So right here, we passed the close modal function into the add event listener function as if it was just a regular variable, right? And actually, not all languages have first-class functions, but JavaScript has, and it is amazing. Believe me, it's really, really helpful. Next, I said that JavaScript is a dynamic language, and dynamic actually means dynamically typed. So as we've already seen, in JavaScript, we don't assign data types to variables. Instead, they only became known when the JavaScript engine executes our code. Also, the type of variables can easily be changed as we reassign variables. And this is basically what dynamically typed means. Now, there is a lot of controversy if this is good or bad, but this is just how it works. Now, the same is not true for most other programming languages, where we have to manually assign types to variables. And this then usually prevents bugs from happening, which is the reason why many people say that JavaScript should be a strongly typed language as well. And if you yourself want to use JavaScript with types, then you can always look into TypeScript. But anyway, let's now finally talk about the single thread and the non-blocking event loop concurrency model. Now, this is a really complex topic, and probably the most complex one of the whole course, which is why it's kind of at the end of the course. And therefore, I'm not going to go into specifics here just yet, but instead I will just define some things here. First, what actually is a concurrency model? Well, it's just a fancy term that means how the JavaScript engine handles multiple tasks happening at the same time. Now, okay, that's cool, but why do we need that? Well, because JavaScript itself runs in one single thread, which means that it can only do one thing at a time. And therefore, we need a way of handling multiple things happening at the same time. And by the way, in computing, a thread is like a set of instructions that is executed in the computer's CPU. So basically, the thread is where our code is actually executed in the machine's processor. All right, but what if there is a long-running task, like fetching data from a remote server? Well, it sounds like that would block the single thread where the code is running, right? But of course, we don't want that. What we want is so-called non-blocking behavior. And how do we achieve that? Well, by using a so-called event loop. The event loop takes long-running tasks, executes them in the background, and then puts them back in the main thread once they are finished. And this is, in a nutshell, JavaScript's non-blocking event loop concurrency model with a single thread. It sounds like a mouthful for sure, but in the end, it really just compresses to this. Just keep in mind that, again, this is a huge oversimplification that we will come back to. All right, and this actually rounds up this overview lecture. I know there was a ton of stuff to take in, but I hope that you still learned a thing or two here.